All right, I want to do the quiz for week 6. We struggled a little bit. So it was Engineering 305. This is the quiz for week 6. We're going to work on the solution. I'm going to work on the solution. So here we go. A block that weighs 400 pounds supported by an aluminum cable. It's got my material properties. Cross-sectional area of the wire. If the temperature increases by 50 degrees, what's the stress in the wire? So what we've got is this block is hanging and the temperature increases by 50 degrees and then the block hangs and it starts to stretch that. 120 is my free length. So I've got a strain in the wire or a deflection in the wire. We could think of it either way. We can think of it as the total strain, which this equation is right off our equation sheet, is the structural strain plus the thermal strain. And then I'm going to rewrite that. I'm going to rewrite that delta. I'm not going to write it that big. Delta over L is equal to, that's my total strain, is equal to my structural strain plus my thermal strain. No, I'm not going to write that out in that many steps. This is P. I don't have the L. I divided by that. This is actually the structural strain. So maybe I should write that is the stress divided by Young's modulus, and the thermal strain is alpha delta T. Now, what parts of that do I know? What am I looking for? Well, I'm actually looking for the stress. I'm looking for that right there. How much stuff do I know? Well, you could argue that I know all of it. I know that my deflection is going to be 0.08 inches. Well, I don't know that. It depends on how much the structural strain would pull it down and how much the thermal strain is. So I really have to figure those things out first. So I might want to do I might want to do delta from the thermal as a check equals 120 inches times alpha, which is 12.5 micro, as you guys appropriately called out, per degree F, and then delta T, which was 50 degrees, 50 F. My units are going to cancel out to leave me at the end with micro inches, and I've got to pull up a calculator, so as you know, I always hit pause or try to. So I got 75,000 micro inches, or really that should be rewritten as 0.075 inches. So if my mechanical deflection would be greater than 0.05, then that block is going to be sitting on the ground. So if the block weighed 400 pounds, what would delta be? Well, that's PL. This is my structural PL over AE. And I'm going to calculate that 400 times 120 over 0.15 times E, which is 10 MSI. SI. I'm going to drop the MSI and I'm going to go E6. And I know that this is going to work out equals, my units are going to be in inches. Pause while I hit the calculator. And I got that as 0.032. But you can see I don't have that much to give. That would give me then my delta total would be equal to 0.107, and I can't have that because that's too much. That's too much force pulling the cable to get it to stretch. So I can go all the way back. I can go all the way back to this equation. And I know that delta is, delta is equal to 0.08 divided by 120 is equal to the stress, whatever that is. My stiffness is 10 E6 PSI plus, And then I've got alpha delta T, which is, I had just done that here, 12.5 micro times 50. My Fahrenheit's already canceled. And now I can, and that's my equation. Now I could rearrange this to be that my stress is equal to 0.08 over 120 minus 12.5 times 50. All of that times 10E6. Oh, it ought to work out. Let me hit the calculator. Yeah, so one thing I will point out, I had to add a little micro there, but I got 6.66 e to the negative fourth minus 625 micro, which is 6.25 times 10 to the negative fourth. And then I multiply that by 10 to the negative 6, and I get PSI, 416 PSI. And then your version of the test said, well, what's the tension in the wire? Well, if you know the stress in the wire, the tension in the wire is force is equal to stress times area. And so you could take your 416 times 0.015, and you would wind up getting 62.5 pounds. And that's a good problem. Now, here's what's rubbing me the wrong way as I'm going through and did the grading. There are people that had answers of 1,200 pounds. And I understand stress. There are people that had answers of 6 digits of stress, 5 digits of stress. Fine. I don't have a sense. I can't tell you what's... I pull my finger. I have no idea how much stress there is. I get that. Oh, I understand. But when you're telling me the 400-pound block is putting 1,200 pounds of tension in the cable, you're not thinking through your answer. You're not thinking through your answer to figure out whether that makes sense or not. And so that is frustrating, because that's the thing we got to do. I want you to check units, and I want you to go, 1,200 pounds, how does that compare to a 400-pound box? Okay, let's think about that. Anyway, there you go. That's the solution to that quiz, not the 1,200. We got to get rid of that. I don't want that sticking around. That's those are the answers there. Get my pixie dust out. All right. Equals sigma. I hope you're having a great day. There'll be more.